The internet feels invisible. A message leaves your phone. A payment crosses a border. A video begins playing on your screen. An artificial intelligence model generates an answer. Everything seems to happen in the air, instantly, silently, without friction. But the internet is not software. It is not an application. It is not a website. It is not social media. The internet is infrastructure. And some of the most important pieces of that infrastructure are hidden beneath our feet, under our streets, inside buildings, across mountains, between countries, and beneath the oceans, inside a global network of glass fibers thinner than a human hair. These networks carry the world's data, financial transactions, cloud services, government communications, corporate systems, video calls, search queries, artificial intelligence workloads, and billions of private messages every day across the planet. The modern global economy depends on them, and yet most people never see them. They are buried underground, protected inside buildings, hidden beneath the sea, invisible to consumers, and strategically important to almost every nation on Earth. This is the hidden infrastructure of the internet, not the websites, not the applications, not the platforms, the physical network beneath them. Because the digital economy may appear to exist in cyberspace, but its foundation is built from glass, steel, concrete, electricity, and one of the largest infrastructure systems humanity has ever created. Every time you open a website, something begins to move. Not the website, not the application, but data. Your request leaves your device, travels through your local network, enters your internet service provider, moves into regional infrastructure, crosses national backbone networks, and eventually reaches the destination where the information actually lives. The journey may only take a fraction of a second, but behind that speed is an extraordinary engineering system. The internet is not one giant network. It is a network of networks. Thousands of independent networks connected together. Internet service providers, cloud companies, universities, governments, financial institutions, content delivery networks, and technology companies. Each operates its own infrastructure. Each manages its own routes. Each exchanges data with others. Together, they create what we simply call the internet. It appears seamless, but beneath the surface, millions of routing decisions are made every second. Data is constantly choosing the fastest path, avoiding congestion, finding alternative routes, moving across infrastructure built by different organizations. The experience feels simple. The architecture is anything but. Every click depends on cooperation. Every connection depends on infrastructure. And every digital experience begins long before the information reaches your screen. Because the internet is not a destination, it is a journey across one of the most sophisticated infrastructure systems ever constructed by humanity. When people talk about the cloud, it sounds like something floating above the world. Every file, every email, every website, every artificial intelligence model appears to exist everywhere at once. But the cloud has an address. Every website lives on a server. Every application runs inside a computer. Every database exists inside a storage system. And every one of those machines is located somewhere on Earth, inside buildings known as data centers. These facilities are among the most important buildings of the digital age. Rows of servers operate day and night, processing information, storing data, delivering content, powering businesses, supporting governments, training artificial intelligence, and serving billions of people simultaneously. But a data center cannot operate alone. It must remain connected every second to thousands of other networks around the world.
That connection happens through fiber optic infrastructure, high-capacity backbone networks, and internet exchange points. The building becomes part of something much larger, a global architecture where information is constantly moving between facilities, across cities, across countries, across continents. The cloud is not one place. It is thousands of physical locations working together, each connected by infrastructure, each dependent on electricity, cooling systems, network equipment, and continuous communication. The internet feels limitless, but every digital service ultimately depends on buildings that occupy real land, consume real power, require real engineers, and connect through real infrastructure. The cloud may appear invisible, but behind every digital experience, there is always a physical address.
Imagine a city without intersections. Every road would eventually come to an end. The internet faces the same problem. Thousands of independent networks exist around the world. Internet service providers, cloud companies, universities, governments, financial institutions, content delivery networks. Each builds its own infrastructure, but eventually, those networks must meet. That meeting happens inside facilities known as Internet Exchange Points, or simply IXPs. An Internet Exchange Point is not the Internet itself. It is where different networks exchange traffic directly with one another. Instead of sending data across longer and more expensive routes, networks can connect locally, reducing distance, reducing cost, reducing latency, making the internet faster, more efficient, and more resilient. Every second, enormous amounts of data flow through these facilities. Video streaming, cloud computing, online gaming, financial services, artificial intelligence, business communications, billions of digital interactions. Most users never know these buildings exist. They simply experience a faster internet. But beneath that experience, a complex physical architecture is constantly operating. Fiber enters the building. Routers exchange traffic. Engineers monitor performance. Networks negotiate connections. And information continues its journey. The internet may appear to be one seamless system, but behind every connection, independent networks are constantly working together. Because the internet was never designed as one giant machine. It became a global system by connecting thousands of smaller ones.
Every neighborhood has a local road. Every city has a highway. The internet is no different. Behind local internet providers, behind office networks, behind mobile carriers, exists another layer of infrastructure, known as the backbone. These are the highest capacity communication networks on Earth, designed to move enormous amounts of information across vast distances, connecting major cities, connecting countries, connecting continents. Built with thousands of strands of fiber optic cable, each capable of carrying extraordinary volumes of data, using pulses of light, traveling through glass at nearly the speed of light. This is where the internet becomes truly global. A search made in Singapore, a payment processed in London, a cloud server operating in Virginia, a business application running in Frankfurt, all become possible because backbone networks connect them together. But these networks are not owned by a single organization. Some belong to telecommunications companies. Others are operated by cloud providers, content delivery networks, national infrastructure operators, and global technology companies. Each invests billions of dollars to expand capacity, increase resilience, reduce latency, and support the ever-growing demand for digital services. The backbone is rarely seen. Few people know where it runs. Even fewer understand its importance. Yet every modern digital experience depends on it. Without backbone networks, there is no cloud, no global business, no international finance, no real-time collaboration, no modern internet. Because before information can reach your screen,
It must first travel across the digital highways of civilization.
Continents are separated by oceans. People are separated by geography. But the internet cannot stop at the shoreline. It must continue across thousands of kilometers through one of the most hostile environments on Earth, the deep ocean. Contrary to popular belief, satellites do not carry most of the world's internet traffic. The overwhelming majority travels through submarine fiber optic cables, resting quietly on the ocean floor. These cables connect continents, countries, financial markets, cloud regions, governments, businesses, and billions of people. Inside each cable, thin strands of optical fiber carry pulses of light. Each pulse represents information, a message, a payment, a video, a software update, an artificial intelligence request, traveling across entire oceans in fractions of a second. Building these systems is an extraordinary engineering challenge. Specialized ships carefully deploy the cable across the seabed. Near coastlines, the cables are buried beneath the ocean floor to protect them from anchors and fishing equipment. Farther offshore, they rest thousands of meters below the surface, where darkness, pressure, and isolation define the environment. Although they remain hidden from public view, these cables have become critical infrastructure. If one route is damaged, traffic must immediately be redirected. If multiple routes fail, entire regions can experience slower connectivity, economic disruption, or even temporary isolation. The digital world appears wireless, but its international connections depend on physical cables lying silently beneath the sea, invisible to almost everyone, yet carrying the conversations, the commerce, the knowledge, and the intelligence of modern civilization. Because before the internet became global, engineers first had to connect the world, one cable at a time.
Every search begins somewhere. Every website loads from somewhere. Every cloud application operates somewhere. That place is a data center.
These buildings are the factories of the digital age. Instead of manufacturing products, they process information, store knowledge, deliver services, and keep the modern internet running every second of every day. Inside, hundreds of thousands of servers operate continuously, each performing a specific task: hosting websites, managing databases, processing financial transactions, streaming video, supporting artificial intelligence, and powering the digital services that billions of people depend upon. But computers alone are not enough. Every server generates heat, every rack consumes electricity, every interruption creates risk. To remain online, a data center requires an entire ecosystem: independent power feeds, massive backup generators, industrial cooling systems, battery infrastructure, fire suppression systems, physical security, network redundancy, and multiple fiber connections linking the facility to the rest of the world. These buildings never sleep. Engineers monitor operations around the clock. Software continuously balances workloads. Power systems prepare for failures before they happen. Every second of uninterrupted service is the result of countless invisible decisions. Most people imagine the cloud as something floating above them. The reality is far more impressive. The cloud lives in some of the most sophisticated buildings humanity has ever constructed. Because behind every digital experience, there is a building designed to never stop operating.
The internet is often described as a digital world, but digital systems cannot exist without something entirely physical: energy. Every router, every switch, every server, every storage system, every fiber amplifier consumes electricity every second, every minute, every hour. Without power, the internet simply stops.
This is why electricity has become one of the most important resources of the digital economy. Modern data centers consume enormous amounts of energy, not only to power millions of processors, but also to remove the heat they generate. Cooling systems, power distribution units, battery banks, backup generators, electrical substations. Every layer exists for one purpose: to keep information flowing without interruption. Even a few seconds of downtime can disrupt financial markets, interrupt global communications, delay cloud services, or disconnect millions of users. Reliability is no longer a convenience, it is a requirement. As artificial intelligence continues to expand, the demand for electricity is growing even faster. Every AI model requires extraordinary computing power, and every computation requires energy. The future of the internet will depend not only on faster processors, but also on stronger electrical infrastructure. Because behind every intelligent system, there is a power system. Behind every cloud, there is an electrical grid. And behind every digital civilization, there is an energy infrastructure working silently in the background. The internet may appear to be made of information, but without electricity, information never moves.
Infrastructure does more than move information. It shapes influence. It creates opportunity. And over time, it concentrates power. Every new fiber route changes connectivity. Every new data center attracts investment. Every new internet exchange strengthens an entire region. Infrastructure is never just infrastructure. It becomes an economic advantage. Businesses choose locations with better connectivity. Cloud providers expand where reliable infrastructure already exists. Artificial intelligence grows where computing power is abundant. Investment follows capacity. Innovation follows investment. And prosperity often follows innovation. This is why nations invest billions of dollars in digital infrastructure, not simply to improve internet speeds, but to strengthen their economies, increase competitiveness, attract technology companies, support research, and secure their position in an increasingly digital world. The same principle applies to businesses. Companies that own infrastructure control critical pathways of the digital economy. They provide connectivity, host applications, store information, process transactions, and enable entire industries to operate. The internet appears decentralized, but many of its most important foundations are highly concentrated. A relatively small number of networks, facilities, cable systems, and infrastructure operators support an extraordinary portion of global digital activity. This concentration creates efficiency, but it also creates responsibility, because when infrastructure becomes essential, its importance extends far beyond technology. It becomes part of national resilience, economic stability, and global influence. The internet is often described as an information network. In reality, it is also a network of infrastructure, and wherever infrastructure becomes indispensable, power inevitably follows.
The internet changed the world. But the internet did not begin with software. It began with infrastructure. Before a website could be visited, a network had to be built. Before cloud computing became possible, data centers had to exist. Before artificial intelligence could answer questions, fiber optic networks had to connect continents. Every digital breakthrough rests upon a physical foundation: glass, steel, concrete, electricity, engineers, machines, working together, every second, every day. Most people experience only the digital layer, the applications, the platforms, the services,
the convenience. But beneath everything, there is another world, a world of infrastructure, quietly supporting billions of lives without recognition, without attention, without stopping. This invisible architecture has become as essential as roads, ports, railways, airports, and power grids. Because modern civilization no longer moves only through physical transportation, it also moves through information, across fiber, between data centers, through networks, across oceans, at the speed of light. The future will bring faster networks, larger data centers, more powerful artificial intelligence, and entirely new digital industries. But every innovation will continue to depend on the same principle. Infrastructure comes first. Everything else is built upon it. Understanding the internet is not about understanding websites. It is about understanding the architecture that makes the digital world possible. Because when you understand infrastructure, you begin to understand business, technology, power, and ultimately, modern civilization itself. This is only the beginning, because before we can understand the digital world, we must first understand the architecture beneath it. Welcome to NextNet, the architecture of modern civilization.